Hello everybody, it's Teacher Tenny here again. I'm from Edify Math and Science. Today we're here to talk about the DC circuits, the main topic for secondary 4 physics. Right, so this is a DC circuit, so we have both the series and parallel circuit. So we'll first touch on series circuit. To find series circuit, the resistance for series circuit is very simple. You just have to add them up together. Alright, so over here we have the 2 ohm resistor and the 4 ohm resistor. So the total resistance is just 2 plus 4, 6 ohm. Alright, so remember the unit for resistance is ohm. Alright, now the value of ammeter. For this particular chapter, the main formula that we have to know is R equals to V over I. So with this, you would be able to solve most of the questions in this chapter. So ammeter means you need to find the current passing through it. R is the resistance. V is the voltage or the potential difference. I is current. Okay, with this we should be able to find most that we need. So since now I need to find I equals to V over R. Okay, this A here measures the total current. So total current, then I have to use the total voltage, which is 6, over the total resistance, which is 6 here given. Not given, you counted, giving you 1 ampere. Alright, let's now find the value of V1. Okay, V means the amount of potential difference across the 2 ohm resistor. So we already mentioned, okay, voltage across the 2 ohm resistor. So we want the 2 ohm resistor, and the current passing through is 1 ampere. So this will give us 2 volts. Alright, then for V2 in the same manner, V2 equals, so V2 is the resistance across the 4 ohm resistor. So resistance is 4, current that we have counted is 1, hence is 4 volts. Okay, so this is 2 volt, this is 4 volt. You realize that these 2 and 4 will add up to the total total voltage of the battery. Okay, so the amount of energy is split among the 2 resistors. Okay, but the total current remains the same. Alright, so take note, this is how a series circuit will look like. Alright, now let's look at this is a parallel circuit. The way to find the total resistance for a parallel circuit will be slightly different. So for the total resistance is 1 over R1 plus 1 over R2. So depending on how many resistors are there, if there are 3, then plus 1 over R3, then you inverse it. Alright, so in this case, for the total resistance would be 1 over 2 plus 1 over 4 inverse. So that would be 1.33 ohms. Okay, now let's find the value of A1. A1, like we said just now, I equals to V over R. Okay, V in this case is 6. Resistance, because it's the total resistance that we are looking at. So 6 divided by 1.333. So if 1.33 is, we got it from the half plus 1/4. Alright, so not a very difficult number. So answer would be 4.5 ampere. Alright, so that's the value for A1, 4.5 ampere. Alright, let's look at the now for A2. So again, now A2, okay, maybe we write A2. So that will be same thing, V over R. So this time is the current through the 2 ohm resistor. Okay, so 6, that's the only voltage value that we have anyway. Over the resistance, because it's 2 ohm resistor, is 3 ampere. So this is 3 ampere. So now for I3, using the same way again, V over R, V is 6, R, because they want A3 is the value of the ammeter across a 4 ohm resistor. So it will be here, therefore it's 1.5 ampere. So if you take note of these, so for just now, the series circuit, the voltage is split, but the current is the same. But for this case, the voltage is the same for both of them, but the current splits. So if you realize, the 3 ampere plus the 1.5 ampere will actually give you the total current that is passing through A1. So if you realize, what happens is the current come here, it will split here and then return here back again. Alright, so that's why it is the value is as such. Alright, so that is what we have seen for both the series and parallel circuit. Of course, during exam, it can come out as series and parallel coming up together. So this is one example. So how we find the total resistance? So these two is in parallel, but is in series with these. So how do we find? So it will be 1 plus 1 over 2 plus 1 over, so same thing like what we found just now. Okay, so answer will give us 2.333 ampere, ohm, sorry. Okay, ohm. Okay, so now let's find the value of A1. So A is the total current that we are looking at. So when it's on the outside alone, it's the total current. So to find the A1, okay, same thing is V over R. The total V in this case is 6. The total resistance we counted is 2.33. So that is what we have done. So same thing, now we find, okay, how do we find this? Okay, you get a value of 2.57 ampere. Alright, so now we find the value of V1. Okay, V equals to IR. So the value of I in this case is 2.57. Okay, maybe we write the formula down. Okay, IR. So in this case, the I is 2.57 because now it's the voltage across the 1 ohm resistor, so we use 1. Hence it's 2.57 volts. Alright, so now if we want to find V2, V2 is here, so we need to find the total resistance here, which was 1.33. Hence V2, the value is still, I is still 2.57 times R in this case is 1.33. Okay, so if you multiply them together, okay, you would get a value of 3.43. Okay, so you realize that when you add them up together, okay, you will get a value of the 2.57. I mean value of 6 volts when you round it off. Alright, so you see these two will add up to 6. Okay, so that's how they are related. So now if you want to find the value of A2, so using the same logic that we have learned, okay, now to find A2, so to find A2, what you need to do is same thing, A2, V over R, but which V are we looking at? So this time is V2's V, so 3.43 divided by the resistance, which is 2, that you will get, this would give you 1.72. Okay, then if you want to find later A3 again, so for this case A3 would be same thing, V over R. So this time the V is 3.43 and the R is 4. So 3.43 divided by 4 will give us 0.86. So you realize later that these two will give you your will add up to your when you round off, you will add up to the same value of A1. So in that case, that's how we find that's how all the ammeter readings and the voltmeter readings are related to each other. So these are very common questions that we would see in exams. So hope you get a better understanding. Thank you.